Hello, good evening, all of you. Hi, Rohini, Shakin, Yashashwani. Hi, I'm audible. If I'm audible, please reply. You can put thumb up in the chat box. If I'm audible, please reply. Hello, Prajit, Prem, Yalla, Sudhakar, Posh. Yes, good. Okay, so today what we are going to, yes, thank you, Yashashwani, Sudhakar, Sai, good evening, Rohini, good evening. Yes, so today we are going to discuss few things. Bharat, hi. Today we are going to discuss few things. We have to understand, we have to learn. Today we are going to start very basics of Coulomb's law. Okay, basics of electrodynamics. That's the very first topic we take. We will take Coulomb's law. Harshita, I'm good. How are you? And Sakin, okay, Satya, good. Okay, so maybe in duration of this class, maybe I'm not able to sometime reply your queries or your questions. So be flexible with this, and we will try to learn the topics that would be more important in this class. Okay. So now we are going to start the class, and before going to start the class, I will tell you a few things you have to learn first. That is the why we are going to start this topic, and why I choose this topic for your classes. The very first thing is there, that is the electrodynamics we are going to start. In electrodynamics, actually there are 7 chapters. That means 12th class, the first part book. If you see, there are 4 books of physics, 11th 2 part and 12th 2 part. So 11th class first part, if we are taking it, so 11th class first part, that we call electrodynamics books actually. Electrodynamics, not aesthetics. Okay. So electrodynamics, there are approximately 7 chapters we are having. Okay. I will tell the name. That the first thing is the we can say electric charges and electric field, then electric potential and capacitance. The third chapter is the current electricity. The fourth chapter is the moving charges and magnetism. And the fifth chapter is the magnetism and matter. And the sixth chapter we say the electromagnetic induction. Then we can say the seventh chapter, that is the alternating current, that is also part of this. And the next chapter, eighth chapter, is the actually electromagnetic waves. These are actually 8 chapters definitely. Okay, so this is a part of electrodynamics, but this portion is very important for the exam point of view. I will tell you, in this year, in the 2025 also, if you see the out of 45 questions, there are actually approximately 11 questions from we can say from this portion only, electrodynamics. So 11 12 questions from this part, we will see those questions. Okay, so that we will learn with the time, one by one we will discuss. But now I am focusing on the one important topic, ki why electrodynamics the important for the 12th. So in electrodynamics, I told you the 11 or 12 questions recently also this year, and the previous years also, if you see, approximately the same number of questions were there. So 11 questions this year, that means approximately 25%. That means 1/4 of the actually paper was from the electrodynamics. So that is the important area that we have to learn. Okay, one thing. And the second thing, if we are talking about one more thing, what we are going to start today. So today I will discuss the very basics of the electrodynamics. So for the basics, the very important is what is the electro, and the second word is the dynamics. When we are talking about the electro and dynamics, so we will see those part. Okay, so I'm just taking care of that part. Though you can see the first thing is the electrodynamics. Excuse me, this pen, please. Not this one, just wait. this one, this file I want to write. This, okay, okay. So we are going to understand the few things first, that the electrodynamics. Okay, I think I have to change the color. That is not a good one, so I will change the color. That would be better. So I'm writing again. You can see the electrodynamics. Electrodynamics. This is our topic, today's topic. So when we are talking about the electro, what is the meaning of electro? That means that the actually charges. Okay, that we are talking about the charge. And the second word is the dynamics. When we are talking about dynamics, means it is related to the motion. Okay, it's the motion. So dynamics, when we are talking about, that means it's related to the motion. Just like we have studied the thermodynamics, thermo means heat and dynamics related to the motion, that means work. So we studied like that in 11th class. Similarly, we can talk about the charge and the motion we are talking about. That means motion can be there, rest can be there, motion can be also different kinds. Suppose if I say this is rest, okay, this is rest is there. If second we can say the motion means uniform motion, it can be uniform motion, I can write. The next point we can say uniformly accelerated motion. Uniformly accelerated motion we can study. Okay, so this is a very simple thing, and accordingly we can say non-uniformly accelerated motion. These are few things. So when we say the charge at rest, that we call it electrostatics. What we call it? Electrostatics. So we can talk about this is the electrostatics. So it's the electrostatics is there. So our few classes, starting few classes would be focused on this part, electrostatic. When we talk about the motion, that means it is related to the that we call the uniform motion. It is a current electricity topic, we will study about it. Okay, in the current electricity we will talk about this. Not only in this current electricity, we will study the same thing in the moving charges and magnetism also. Moving charges and magnetism. Okay, so that are the few things we can talk about. So these are few things we have to learn that we are going to study, and after that we can discuss the EMI topic also, and then we can see the AC also. In the AC also we will learn it, and the last topic when we say the accelerated motion, from that we can produce that EM waves, electromagnetic waves. So when the charge is there, and due to this charge, if motion is there or rest is there, then what can be the possible cases are there, that we call electrodynamics. So in this course we will try to complete, fulfill the requirement for this topic, that the electrodynamics. Okay, so we are going to start from a very simple thing, that is equal to charge at rest first. So charge at rest means electrostatics. So first we will go for electrostatic portion of this big unit, that is the electrodynamics. We can go for it. Okay, so we are going to discuss few more things. What are the charge, what is the at rest meaning, what are the electrostatic meaning, we will discuss now. Now, if you see electrostatics now, okay, electrostatics. Okay, okay, the few students are replying. Chandana, Sri, good evening. the stellar, okay, dark ritual. Thank you. I'll try to give the more and more good examples that will help you out. Okay, Priyanshu Paul. Definitely, I will give you the more and more advices with the class when you learn it. Definitely, it will help you out in the classes also, and after that in the your daily life also. So you have to be more cautious, more learning, then it would be good for you. Okay. Now we will try to focus on the topic, that is the electrostatics. When we are talking about electro, just now we have discussed that is the meaning charge. Okay. And when we talk about the statics, means at rest. So when we say the charge at rest, that means our focus would be in one case that we call the charge is not moving, charge is at rest. Charge is not moving, charge is at rest. So very first thing comes to you, ki sir, please tell us what is the meaning of charge. So when we are talking about the charge, I will talk to you that the charge is one inherent property of the matter. So when charge is there, that means matter is there. So it can have charge. I'm not saying it will always have charge. I'm saying it can have a charge, just like mass. Matter is having matter. When we say the matter means it is having mass, it is having volume, definite size we say. Definite size, or we can say volume it is having. So that we call matter. The matter can have mass. Okay, that will have definitely mass. But it will have charge or not, it may possible, may not possible. But if charge is there, definitely mass would be there. If charge would be there, definitely mass would be there. That means charge is always associated with the mass. But mass is not always associated with the charge. That is the very first thing. Okay. So charge is a property of the matter. Charge is the property of matter. First thing we have to learn it. Now, second thing comes to you, ki how many types of charges are there? So mass is there, no meaning of mass, ki it can be positive or negative. But when we talk about the charges, charges can be positive also, charges can be negative also. Just like we call in the chemistry also, you have studied that the positive charge is there, negative charge is there, proton is positive charge, okay, and we can say electron is negative charge. That's a very basic thing. And according to that, you have studied in the chemistry also, in the physics also, electron is revolving around the nucleus in a circular orbit. So electron is revolving around the nucleus in a circular orbit. That is the electron is negative charge, and this center we call say nucleus, that is the positive charge, because protons are present in that the nucleus. So you will see ki there the one there the one we can say force of attraction is there. The force of attraction due to their opposite charges. They are opposite charges, that means there can be force of attraction. So that is another property we are learning, that when charges are opposite nature, they attract each other. Then charges are same nature, that means like charges are there, positive positive or negative negative, then we call that as actually repelling each other. So when they are like nature, that they repel each other. When they are unlike nature, they attract each other. That is another kind of property that we are learning. So few property we will discuss here, you will understand. Okay, so I'm taking to the next slide, you will understand. These are few properties I have written here. The electric charges and their property we will discuss in detail, don't worry about it. Okay, so charge, it can be positive, it can be negative. You can see this is a positive as well as negative. I told you there's two types, and you have to understand very carefully that this electric charges is the property of substance. Property of substance. Okay, and yes, I will request to all of you, if you are going to continue with this classes, definitely stellar. Thank you. I am also missed my students. They are always good. Okay, so I respect your feeling. Thank you, beta, and good evening. Good evening, beta. Good evening, all of you. Good evening. Now, please understand. These are the property of substance when we are writing. So the whatever I will discuss in the today's class or in the coming classes, I request you please make some notes. Okay, you can take one A4 size paper, or you can take some copy. Just write few things. Okay, just few things you will write. Definitely it will help you out to relate the things, because I'm telling you today's class is very introductory type class. I am taking it. But in the coming classes, you will understand that from the basic point we will take to the advanced question. Advanced, I'm not talking about the J advanced, I'm talking about the one good questions we will solve from the basic question, basic concept only. So please write those concepts. So please take up one pen and paper and please try to write it down. Okay, now understand. The charges are positive and negative, so they can be positive and negative. Like charges repels and unlike charges attract. So you have to be clear about it. What is the meaning of that? Positive attract, repel each other. Positive, negative attract each other, but negative repel each other. You have to understand. Okay. Now come to charges. They are conserved for an isolated system. If this system is there, I am giving a very simple example. Suppose this room is there. I am sitting in this room, and in this room, the technical team is sitting there. Okay. So suppose there are 4 persons are sitting, including me. So there are some instruments also present in this room. The camera is there, television is there, lights are there, AC is there. So few things, board and everything. If we include all the stuff in this room, and this is a room is closely packed, that means even the air cannot go inside this air, a room, and it cannot leave this room. So it's a closely packed. Suppose I'm assuming it. That means the total charge of this room will remain conserved. It is not going to change. Now question comes to our mind, sir, what are the meaning of that? Yes, I will explain it. Maybe suppose in starting I am having only 100 Coulomb of charge. This Coulomb is actually the unit of charge. We will learn it. Okay. Now I am repeating again. Suppose I am having 100 Coulomb of charge, and in this room nobody or no article or any substance does not have any charge. I am assuming it. So I am having only 100 Coulomb of charge. Now I can distribute to the all persons or all things. Okay. Suppose one person is having 1 Coulomb or 2 Coulomb or 3 Coulomb or like that. I am distributing complete room the charge. But any point of time, if I add all of that charge, that will remain only 100 Coulomb. That is not going to change. You have to understand this thing. Because charge neither can be created nor can be destroyed. Now question comes to us. So this type of statement we have seen somewhere. We have heard. What is the meaning of that? Neither can be created nor can be destroyed. One statement over there. That is the actually conservation of energy. We have studied. Yes. That the conservation of energy neither can be created nor can be destroyed. Similar statement I am saying here, that charge neither can be created nor can be destroyed. Both are similar statement. That means we are understanding the few laws of nature. What are the laws of nature? The very first thing I am telling you, there are 4 fundamental laws of nature. Very first law, that we call it conservation of energy. That means energy neither can be created nor can be destroyed. The second law I am talking about, that the conservation of linear momentum. You have studied in the mechanics. I am repeating again. That means if the net external force acting on a system or a body is equal to 0, then its linear momentum remains conserved. The third law we study, that is equal to conservation of angular momentum. If the net torque acting on a system or a body is equal to 0, then its angular momentum remains conserved. The fourth law, that is very important, in electrodynamics we are studying, that is equal to conservation of charge. That means if the system is isolated, then the total charge of the system will remain conserved. Or we can say charge neither can be created nor can be destroyed. These are 4 fundamental laws of nature. You have to learn it very clearly, remember it. And I am telling you, any process, any kind of process in this nature is occurring, they have to follow these 4 laws. Without following this law, the natural processes are not possible. Okay, beta. Yalla, Sudhakar, I will tell you, conservation of mass is included in the conservation of energy actually, beta. Okay, in the nuclear chapter in the 12th class we will learn it, that mass is not separately conserved. The very famous equation I will write it, that is equal to delta mc square. Equal to delta mc square. This is Einstein's equation. Einstein's energy mass equivalence equation we call it. And in this equation, if you see it, That means mass can be converted into the energy and energy also can be converted into the mass. And based upon this, there the nuclear reactions are possible. Okay, either it is a fission process or it is a nuclear fusion process. In the both case, you will understand that this is the energy and mass. They are actually one form of other. Okay, that means mass can be a form of energy, energy can be a form of mass. So generally we take the energy, that is the one keyword. So we are taking the system's energy or universe energy, because universe is itself a isolated system. That means its total energy of this universe is conserved. Similarly, the total charge of this universe also conserved. But there is a one here key point I am telling you. Please focus on the board. When I am saying it, the conserved means there's some confusion also comes to the mind. That means charge neither can be created nor can be destroyed, we call it. But I am not saying that number of charge particle is constant. I am not saying number of charge particle constant. Just like I have given one example, in this room, suppose initially I am only having charge. In this room only I am a charge particle. But then I distributed the charge to all the particles. That means the number of charge particle is not conserved. Total charge is conserved, but charge particle is not conserved. I am giving another example. Suppose I am giving you one neutron is there. Okay, it's the one nuclear reaction beta. You can understand now. And in a one neutron is there, and this neutron can be broken down into the one proton, okay, one electron and one anti-neutrino. This is the nuclear reaction. In the nuclear chapter we will learn this topic. And similarly, one proton can be broken down into the one neutron plus one positron plus one neutrino. This is also reactions. I am just not going into too much detail, but I am telling you few things here. The very first thing is that this first reaction, if I am talking about this first reaction, if you see, and this is the second reaction. This first reaction we call it actually beta negative decay. Okay, and the second reaction we call it beta positive decay. Okay, you can forget the name right for now, but understand the concept what I am going to tell you. Okay, please understand. What are the topic that I am just discussing here? There is the one neutron was there. It's the neutral, and this neutral neutron is making one proton and one electron. That means initially neutron is having no charge, but finally the two charge particles are created. Two charge particles are created. You have to understand. Initially there is a no charge. Initially no charge particle, but finally there are two charge particles. So it can be possible. Here one proton is there, finally the one neutron and one positron. We call this positron. It is not proton beta, not electron. It is a positron. You have to understand it. So this positron is created. So initially also one charge particle is there, and final also one charge particle is there. Neutron is not charge particle. Okay, there is no charge. So you have to understand very basic. That means the number of charge particle can be changed. Number of charge particle can be changed. It is not compulsory that the number of charge particle will remain same. This is the another meaning of this conservation of the isolated system. And remember this thing, isolated means that inflow and outflow of the actually matter is not allowed in this system. Clear? I am giving another example, you will learn it. Quantization. Charge is quantized. The quantization of charge. What is the meaning of quantization? It's a very common word come to our mind. Quantization, quantization, quantization. Yes. We have learned in one topic, that is the atom. In atom chapter, there is a Bohr's principle is there. Bohr's quantization principle of angular momentum. That we have learned. Okay, the quantization word we have heard somewhere. So when we say the quantization word we have learned, so what is the meaning of quantization? That we have to learn now. Okay, so quantization means anything we are representing here, okay, that should be the multiple of and one small quantity, integer multiple. What is the meaning? Suppose I'm going a one shop. I'm giving a one example, very simple example, understand. Suppose I'm going a one shop and I want to buy oil. Very common example I always give in my classes. So you have to listen carefully. I'm going for a buying a oil, okay, and for cooking purpose. And what is happening? The shopkeeper is having oil, but that is not packed oil. It is unpacked oil. I mean, a one, we can say, container. It is a filled, and from that he can give me the oil. That's the very basic. But he is having some utensil for measurement. So there are different kind of utensils are there. Suppose one is 1 liter, half liter, or 100 ml or 10 ml. The smallest beaker he is having, that is the 10 ml beaker or container he is having. So that means if I'm asking to that person, please give me the 5 ml or 6 ml of oil only. So can he give? The answer is no. He cannot give. Why he cannot give? Because he can give only multiple, because smallest beaker he is having, that is only 10 ml. So he can give 10, 20, 30, 40 like this. Suppose I am asking the same shopkeeper, please give me the 12 ml of oil. So it is possible for him? So answer is definitely no. He can give 10 or 20 or 30, 40 like this. So there the quantum means smallest beaker he is having. He can give you only the integer multiple of that beaker. There is no meaning of that. Okay, to try to understand it. You have to clear about it. Oh, that means when we are saying the quantity, means there should be some smallest unit, and anything you will get, that should be the integer multiple of this. Now understand my words, I am getting into detail. For the charges also, the smallest charge we are having, okay, that is the charge of electron. I am repeating again, the smallest charge we can have, that is the charge of electron. But there some students comes to class and ask the doubts. So why you are talking only electron? Why you are not saying proton, sir? There can be possible a proton also. Definitely, it's the equal charges are there. The values are equal. Her sign is definitely opposite, negative and positive. But if there are values are the same, that is the E we represented. The charge of electron and charge of proton, magnitude value is equal. So why you are showing only the electron? Why not saying proton? In some books, literature, it is written you can take proton and electron. But I generally prefer the electron charges. Why? Because any body actually is charged due to the motion of movement of electron, not the proton. I am saying body. Remember this thing. I am not talking about individual elementary particles, electron, proton. I am talking about body. When we are talking about body, any body can be charged by the movement of electron, not the proton, because protons reside inside the nucleus, and nucleus cannot be broken very easily. For that, nuclear reactions are required. So actually, who is moving from one body to another body very easily? That is the electron. In the whole chemistry, actually based upon the movement of electron. The movement of electron or its a displacement or anything is there. Based upon that, the chemistry you study. Okay. So actually, the charge, any body is going to charge. So that is due to the motion of electron. That's why I am saying the quantization principle. That means smallest unit of charge, that is the charge of electron. You can take proton also. Not incorrect. I am preferring it. Okay. Now come to the next thing. Sometimes this quantization principle, when we say, there's one more depth you have to learn. When we say that quantization principle, that means any charge you will take, that would be the integer multiple of charge of electron. Try to understand. I am giving one example. Suppose I want 10 electron charge. It is possible. The answer is yes. So when we say charge 10 electron, it can be plus also, it can be minus also. Yes, it can be plus and minus, both is possible, because charge can be positive and negative, it is possible. So what is the value of E? So we have to understand the E value is equal to 1.6 into 10 to the power minus 19 Coulomb. And Coulomb is the unit of actually what? Charge. So charge SI unit is equal to Coulomb, that you have to learn it. Very basic. Okay. So we can write the full name of Coulomb, that is equal to Coulomb. We are going to understand it. Okay. It is denoted by capital C. I'm writing here, that is the capital C. Okay. That's the Coulomb. So I want to write the total charge. So you can say directly Q is equal to 10 into 1.6 into 10 to the power minus 19 Coulomb. That means 1.6 into 10 to the power minus 18 Coulomb. This is the meaning. Okay. So now understand. So I have given one example. Now return to my original example. There is a one shopkeeper is there, and the smallest beaker he is having, that the only one thing, that is the 10 ml. That means any oil I will ask to the person, he can give me only integer multiple of 10 ml. Meaning that means I can take 10, 20, 30, 40 like this. But he cannot give me what value? He cannot give me what? 12 ml, 13 ml, 14 ml, like that he cannot give. Very basic. I have given you example. But understand, suppose I am asking that same person to give me 1.2 liter. He can give me? Yes, he can give. If I am asking 1.25 liter, and can he give? Yes, he can give me. Because now the quantity become big. When it become big, so 1.25 liter means actually 1250 what ml. So 1250 ml, it is a multiple of actually 10 ml, so he can give me. So but it is looking like 1.25, I'm saying. So similarly, when we are talking about the charge is big quantity, because it's the smallest quantity, very small quantity, 1.6 into 10 to the power minus 19. But if I ask you, okay, I want 1 Coulomb charge, I can get. If I say 1.1 Coulomb charge, I can get. If I say 1.11 Coulomb charge, I can get. Because this is very big as compared to this. So that means here, if I am taking this much quantity of charge, then there is no meaning of conservation, that quantization of charge. Okay, it is also following the quantization principle. Try to understand it. It is following, but now there is no meaning to understand, put the more and more calculation, it is a quantized or not quantized. Directly it is a quantized, we can say. Okay, so for the big value of charge, this quantization principle having very less significance. There is no meaning of to putting it again and again. Okay, and my request, the team is also putting the message. There are few students are putting spams or want to chat or want to make some good friends here only. It is a bit of physics class. My request is to you, please understand and try to learn. Okay, Prajit, please put your doubts. I will definitely try to explain it. Okay, Yashashani, put your complete statement. I will answer it. My request to you, all of you, please understand, please focus on the class. Please focus. Yes, beta. Prajit, 0.1 Coulomb is possible. I told you it's very big. That's why I have written 1.1 also possible. 1.11 is also possible. It's a very big as compared to 1.6 into 10 to the power minus 19 Coulomb. That's why I'm telling you. Please understand it. This is a Purnima. This is the first chapter of 12th class, beta. Okay, electric charges and electric field. I am just taking only very basic property of the charge. Just started 12th class first chapter, very first topic of the 12th class. So I am not actually jumping from another topic to another topic. I am starting from the page 1. Okay, please understand. Tanishka. Okay, that is a very difficult question to answer. How many days it will take to complete? Your question should be, sir, I am understanding or not? So that would be better. So answering that question, it is a tough. I'll try to complete in a week. Little more time may be possible. Okay, your example relevant to charge. I'm not understanding. Please put your question again. And sir, could you please remove those people? I am trying. My team is trying, beta. Yes, Shoshani. Please, you just ignore those people. In the life also you will find. I'm telling you, the other person who are just focusing on the class. There in the life also you will find that kind of persons who is putting your disturbance. Your focus should be very clear. Okay, what you want in the life, just focus on that. Just ignore the things. There are a lot of people in this part. Okay, so I'm giving a very simple example. There are many people, they do not want to study, but the algorithm of the YouTube is there. Any person can join, there's no problem. They want to learn or they does not want to learn, it does not matter. But okay, but my request to those students is there, very please, uh, if you really not enjoying the physics class, you can ignore it, you can just leave it, no problem. We are not here just to increase the number of views. We are here just to explain the things in a better way. Okay, you can find a lot of people are there and teaching in the YouTube. You can go there, you can put your spams, you will find a lot of people like you. Okay, just ignore those things. Other people, please focus on the class. Any doubt is there, put it. I will definitely try to explain. So when I told you this quantization principle, it is a very significant when the charge is small quantity. A small quantity means you are taking 10 E or 20 E or 30 E or 50 E, like that. At that point of time, it is a very cautious you have to be there. It is a integer multiple of E or not. But when we are talking about when you are taking a Coulomb charge, micro Coulomb charge or nano Coulomb charge, that is a very big quantity. At that point of time, don't try to put too much stress on the quantization. It is already there, so it will become little insignificant at that point of time. Okay, now understand the very important term there. The next point is there, the relativistic invariant. What is the meaning of that? The charges are relativistic invariant. So I am taking to the next slide just to explain it. I am not removing anything from the board. If you want to write, you can write. I will return to this. Don't worry about it. Okay. So I am saying the relativistic invariant. So the charge is there. I told you. Similarly, the mass is also there. When I told you that any system or any matter is there. In the matter, mass is the property of matter. Okay, fundamental property of matter. Similarly, charge is also fundamental property, but it is not always that charge would be there. Charge can be there or not be there. It is possible. Okay, now come to the point. This is a charge is there, mass is there. But when we go to the actually little higher side, when we say the modern physics, in the modern physics, there is the one very important person is there, that's Einstein. The Einstein is there, and Einstein's very beautiful contribution to this world is the equal to delta mc square. But this is a small part of a very big theory there. The theory was the special theory of relativity, and then it's further expanded, and that becomes the general theory of relativity. But definitely in the 12th level, we are not going to study those parts, so ignore it. I am just telling you the few things from that part. There are few points are there, key points are there. I am explaining. Nothing can be moved faster than, no particle can move faster than the speed of light. That is equal to c. That's the few key point I am telling you. Another thing is the time can be different for the different bodies if they are moving at different speeds or at rest. Okay, their mass can be different if they are moving. So these are few things, key points are there. So I am taking just one key point right now here, that the mass is not same. That means if any body is moving with the speed of light or near to the speed of light, definitely nobody can move to near to the speed of light. I'm just telling you, it's the moving near to the speed of light. At that point of time, what will happen? Its mass will change. That was the formula given by the Einstein in the special theory of relativity. So we are just writing that part, that is equal to md is equal to m naught divide by under root of 1 minus v square by beta c square. Okay, I'm just writing little properly, that would be better to you. V square by c square. It's the very simple formula, I'm just writing it. md is equal to m naught by under root of 1 minus v square by c square. Okay, now try to understand it. What is the meaning of m naught? M naught is the rest mass. It's the rest mass. Okay, it's the rest mass beta. And v is the speed of, it is the speed of particle. Okay, c is the speed of light in free space. In free space. It's the very basic thing that you have to learn. One more point is md. md we call it, that is equal to dynamic mass. It's the dynamic mass of particle. It's the rest mass of particle. You can say it's the particle. Definitely it is of particle also. You have to understand it. So when we are saying the dynamic mass, so dynamic mass of particle, you can directly write that is equal to md. That means this it is changing. I am explaining, not try to understand it. You can see very simple. Suppose the particle is moving with the speed of c by 2. So you can take that is equal to c by 2 is there. You can put it. So you will say md is equal to, sir, m naught divided by under root of 1 minus c by 2 whole square divided by c square. Little bit calculation. M naught divided by under root of 1 minus c square cancel, this becomes 1 by 2 square, that is 1 by 4. 1 minus 1 by 4, that becomes 3 by 4. So I can say m naught divided by under root of 3 by 4. Everyone know the root 4 is equal to actually 2. So you can write that is equal to 2 by root 3, that is equal to m naught. Okay, this is the md. Now try to understand that root 3 value is 1.7. 1.7 approximately. So 2 divided by 1.7, this is definitely more than 1, that means more than m naught. So what we learned, when the particle is moving near to the speed of light, its mass increases. Its mass increases. Okay, that we call it relativistic value. That means mass relativistic actually variant quantity. Okay, relativistic variant quantity, but charge is not in variant, it is invariant quantity. That means charge does not change like this. Charge remains same. You are at rest or you are moving near to the speed of light, does not matter. It will remain same. It will remain same. Charge will remain same. So charge is invariant quantity. But when we are talking about the mass, mass is variant quantity. So this is the little more difference between mass and charge. I am just asking the few things till now we have discussed. Okay, what are the properties, what are the similarities, and what are the dissimilarities between mass and charge. So you can say that mass is also fundamental property of matter. Charge is also. But mass is only one kind. We cannot say positive or negative. It is only one kind. But we talk about the charge. Charges are two types. It may be positive, it may be negative. Masses always attract each other. Okay, so the force of attraction is there, that we call it the Newton's law of gravitation is there. Okay, gravitation force is there. But charge can be attract and repel. It is another property. Okay, next, mass cannot be conserved. Mass can be converted into energy, energy can be converted into mass. But charge is a conserved quantity for an isolated system. Next, charge is variant quantity. Sorry, mass is variant quantity, but charge is invariant quantity. Charge is invariant quantity. So you have to be understood. I think up to here, everyone has clear the points what we have discussed. So please put the thumb up, or you can say yes sir, it is clear or understood. So that would be one understanding for me ki you are understanding little bit or not understanding. Please put your thumb up. Please, guys. Only 2 persons. Chitra, Yashashwani, good. Posh, Harshita, good. Other people also you can put it. Be little bit interactive in the class. Lavanya, good. Shakin, good. Nice. Very good. Prajeet. Adilakshmi, good. Padmini, very good. Okay. Chaitra, very good, beta. Now, I'm just discussing few things up to here. The relativistic variant or invariant. What is the meaning of this? Tanishka, very good. Now understand. I'm talking the few more properties are there. Charge cannot exist without mass. I told you. Whenever the charge is there, Prem, Tanishka, Neeraj, Satyanarayan, very good. Eklavya. Sir, this topic is necessary for the class 11th student? Definitely not. But I will say one thing. You are a class 11th. After few time, you will be in 12th. So it will help you out. Just understand. And when you are studying the atomic structure chapter or your chemistry, you will understand much better as compared to the other students. So you can listen the class. Okay. Okay. Dama, Bonnie, if their classes are English and Hindi, definitely I will take in English only. The Hindi is not possible on this platform, but I know quite well Hindi also. Okay. So, but on this platform, I will take classes only in English. Okay. Okay. Now I'm returning back. Now please understand. Any doubt is there, you can put it. I will explain it. The charge cannot exist without mass. Just like I told you, whenever the charge is there, it is an integer multiple of electron. Integer multiple of charge of electron. That means E. Okay. Now understand. That means any body is getting charged. So how it can charge? Either they can be deficiency of electron or it can be excess of electron. Not understood. I'll give you an example. I'm having these two bodies. Okay. You can see these are two bodies. Suppose I have done something. Initially, I am assuming they are having equal mass. I am assuming. By the way, they are not equal. Okay, their masses are different, but I am assuming it. Suppose their masses are equal initially, and I rub it. I did something like this, and after rubbing my hands, I am assuming it is the non-conducting. I have some graphs, but by the way, right now I am not having. But there are something I have done like this. Rubbing, and suppose it become positive and it become negative. Now question is that this pan become positive and this another we can say buttons are there and it become sensor. We can say that's the better, but it's a sensor is there. Okay, and no problem. So this is become negative. Now question is that how it is possible? Definitely initially they were neutral and their masses are equal, but I am saying it is a become positive. How it can be positive? The protons came here. The answer is no. Proton cannot move. I just explained it. Proton remain inside the nucleus. It is not possible for the normal process. We have to break the nuclear reaction. It will be bombarded in this room. It has not happened there. So definitely the protons are not coming. So how it can be positive? So definitely the some electron move out of this body. So when electrons are coming out of this body, this becomes now positive. So where the electron is gone, electron goes to this body. So this becomes negative charge. That means electron came here. Now the second question comes to you. That is if this I can say this pointer is there or sensor is there and this pen is there. I am taking this pen. So pen become positive. So that means electrons are coming out of this body. So I am asking very simple question. It is actually what I have to say. It's having excess number of protons or it is having deficiency of electrons. This is the one question. Okay, you can answer in the chat box. I'm asking you. The second, this sensor is there and it is negatively charged. So what is there? It is a excess number of electrons or it is a deficiency of proton. What is more accurate statement? Please explain it. I'm asking, put the chat box. I'm explaining. within 1 minute I will explain all the things. Put your answers in chat box. I'm just waiting for that. I will explain. Okay. Next, when I'm saying it is associated with the mass, the second question comes to you. Okay. Yes, the few students are putting their answer. Very good. Definitely correct answer. This pan is having deficiency of electron because electron is coming out. Protons are not changing. Deficiency of electron. That means now its mass decreases. Its mass decreases as compared to this sensor. And this sensor's mass increases as compared to this pan. Why? Because the some electron move from this pan to this pointer or this sensor. So what is happening in this pointer? You will see it. Okay, now its mass is more. Its mass is more, and that means it is having excess number of electron, not deficiency of proton. Protons are not going to change. To try to understand, remember it. That means whenever the electrons are moving from one body to another body, definitely it is changing its mass also of the body. That means the electrons are carrying mass with itself. That means charge is always associated with the mass. Charge is always associated with the mass. I think now it is clear to you that what is the meaning of this statement. Now another part. Charge is a scalar quantity. Everyone know, very simple. It is a scalar quantity, and you have to understand there are 7 fundamental SI units are there. In that one is a current but not charge. Remember this is the one current is there. So from that we can write the dimension also and unit also. I'm just explaining it. What are the dimension and unit? If you see here, next page I'm writing it. That means actually current we call that is equal to Q by T. That means Q is equal to I into T. Current is equal to, we remember in a ampere, we measure in ampere, and this is T. It is the dimension of the charge. You have to be clear about it. What are the dimension of charge? This is the SI scalar quantity and its dimension is 80, and its SI unit definitely everyone know that is equal to Coulomb. There is no problem about it. It's a Coulomb SI unit. You have to be clear. Now returning back to this this is always additive quantity. Always additive. What is the meaning? Very simple. Suppose it is having 5 Coulomb of charge, it is having 2 Coulomb of charge. If I add both of them, then total become how much? 5 plus 2, that is equal to 7 Coulomb. Very simple thing. Okay. Good evening. Good evening. Okay. Chitra, will you take classes for boys? That's the another question. We will discuss it later. But right now you have to be focused on the Prem Singh, which campus? Right now we are actually focusing on one thing, that is the Sri Chaitanya Educational Institutions. We are focusing here. Okay. I am related to one center from this Sri Chaitanya campus only. Okay. So don't worry about it. Okay. If you put you can query with the team will reply you from which campus I am related. Okay. Now come to the next point. It is the additive problem. Additive means you can add. There can be positive charge, there can be negative charge. 5 Coulomb charge is there, 10 Coulomb charge is there, you add it, that becomes 15. If 10 Coulomb charge is there, minus 2 Coulomb charge is there, 10 plus minus 2, that is equal to 8 Coulomb charge. You can basically add it. There is no problem. The unit of charge is Coulomb. I'll just explain it. The accelerated charge radiate energy. I told you already in starting electrodynamics, when the charge particle accelerated, it produces EM. It radiates EM wave, electromagnetic wave. Electromagnetic wave is the actually nothing, it carries the energy. That means when the charge particle accelerates, it emits radiations. Radiations means energy. That means it loses the energy with the time. I am giving this statement, this question for you. You will understand why the Rutherford experiment, Rutherford model was failed. What was the key question was there? You have to listen, then you will understand the same answer coming here. Okay, whenever the electrons are moving with the accelerated motion, then it will accelerate emit some radiation. So due to emitting the radiation, its energy will decrease with the time, and it will happen. That's the very basic I have given. These are few key properties of the electric charges. I think it is more clear to you. Okay, so if it is clear, please put your thumb up, and you can say clear or understood. You can put the in comment box. Please put it. I'm just coming to the some questions we will solve now, numerical questions. Very first question, it's the NCERT solved example. You can see it. I have taken from there, and we will solve this. Transfer of 1 coulomb of charge. Okay, if 10 to the power 9 electrons move out of a body, another body every second. Okay, how much time it will require to total 1 coulomb of charge to the other body? This is a one question is there. We are going to put it. Okay, now we have to solve. So we are saying here, beta, very simple thing. What is the charge? What is the rate of charge is flowing out? 10 to the power 9 electrons move out of a body to the another body every second. How much time it is required to get a total charge of 1 coulomb? Now, why I have taken this question? Now you have to understand it. Okay, Shreya, thank you. Thank you, beta. Chitra, I'm not understanding what is the fundamental nature of charge. It can be positive and negative. Okay, very simple. Charge can be of both nature. It can be positive also, it can be negative also. Ramadevi, good, beta. Okay, now understand. Now this question is there. Why I am taking this example? I am just giving you first thing. This example from the NCERT I have taken because it will give you the idea how to calculate the charges, how to calculate the movement of charge, second part, and the third important thing, you will understand what is the meaning of 1 coulomb charge. Because 1 coulomb charge is not very small charge, it is a very, very big charge. Try to understand it. I am repeating again, it is not very small charge, it's a very, very big charge. You have to be clear about it. I am just explaining it. Try to understand. 10 to the power 9 electrons move out of a body to the another body per second. Now try to understand, and how much time it will require to get the total charge of this. Electron, 10 to the power 9 electrons. Now try to understand, this is a 10 to the power 9 is number, electron means this is a charge. We can write 10 to the power 9 into 1.6 into 10 to the power minus 19 coulomb. Okay, it is per second I am talking about. It is a per second. This is happening. This much charge is moving from the body, one body to another body. So you can write 1.6 into 10 to the power minus 10 coulomb per second. Coulomb per second, just now I told you charge per unit time or charge divided by time, that is nothing else, current actually. So I know the current. Current is actually given to you. This is a Q by T is given to you. That is, we can say current. Current is given to you. So now question comes to you, what are the time? So time is equal to Q by I. So total charge is equal to 1 coulomb. What is the I just now we have solved? It's the 1.6 into 10 to the power minus 10. Okay, definitely it is the coulomb per second. Okay, so coulomb cancel, this will go into the seconds. So you can say that is equal to, sir, 10 to the power 10 divided by 1.6, it is equal to second, time is there. Or we can say time can be written as 10 into 10 to the power 9, 1.6 into seconds. Okay, if you solve it little bit, from 4 this is 4, from 4 this is 25, that is equal to 6.25 into 10 to the power 9 seconds. This is the time it is going to happen. Now still I think you are not understanding what is the meaning of this. This time is looking like 10 to the power 9 something second. In second we are not feeling this. I will explain it. If you see the 1 year time, 1 year means 365 into 24 days. 365 days are there. 24 hours is there in 1 day, and 60 minutes and 60 seconds. If we solve it, please give me my mobile. I want to just reduce the calculation time. Okay, I'm just this is a years. You will see how much in 1 year, how much seconds are there. 365, you can say this is the approximately 31536,000. Okay, I'm just approximating this value. 3.2 into 10 to the power, you can check 7 seconds approximately 1 year. In 1 year approximately this is this much second is there. If you divide it, so time would be, this is 6.25 into 10 to the power 9 second, divide by 3.2 into 10 to the power 7. This is second in that means this final answer would be in years. Okay, so you will see approximately 2 into 10 to the power 2, that means approximately 200 years it will take. Now you can understand why I solved up to here. I can leave here also, but I have not left here. I taken to you, then you can understand what is the meaning of 1 Coulomb charge. 1 Coulomb charge is so big value that even after 10 to the power 9 electron every second is moving out of the body. 10 to the power 9 itself is a very big number. That much number of electrons are moving from the body. Then also to get a charge, only 1 Coulomb charge, it will take approximately 200 years. So try to understand, it's a very, very big number. So that's why in complete electrostatic I'm saying it, the most of the time I will take charge in micro Coulomb or nano Coulomb. Okay, not in Coulomb, because Coulomb is a very big number. So try to understand. Got it? Now come to the next question. I think it is clear to everyone. Please reply it. If it is clear, you can put it thumb up or you can put your answer. Okay. Now another question, very simple question I have taken. The charge on a one soap bubble. Charge on a soap bubble. This is not a numerical question. Try to understand it. This is the one very simple conceptual question is there. Already one PYQ is there. Already one PYQ that you have to learn it. Okay. So you will see, suppose there is a one soap bubble is there. It's the soap bubble. Okay. This is soap bubble is there. I'm making little spherical, but my drawing is not good. I will try to draw it again. Let's see. Okay, I am having some images here. No, sorry. I have done something wrong. Can I go back? Please check it. I have done something mistake. Yes, here. Thank you. Just where this pen, how I can take the pen. Yes, thank you. Now think. This is the one soap bubble I am assuming it. And on this soap bubble, if I put the charge, suppose I am taking a positive charge. I am putting a charge on the soap bubble. Now what will happen with the time? That's the one question. Second question comes to you. Suppose this is not positive. It's the negative charge I am putting on the soap bubble. It's the negative charge is there, beta. You have to understand it. It's the negative charge. Now second question comes to you. What is the effect will occur on the this soap bubble 1? I can say this is a bubble 1. Okay, this is the second question. This is a bubble 2. You can put your answers also in a chat box. I will understand. Okay. Fruity beta, I am not understanding what you are not understanding. Please put your question. I will try to explain it. Your doubts, whatever doubt is there, please put it. Okay. I think other people's having clear idea what I have discussed in the class. Okay. Now this is a bubble 1. It is a bubble 2. And bubble 1 I have put the positive charge. And bubble 2 I have put the negative charge. Now question comes to you. Okay. Arjun, what is the problem? You are understanding or not? Please, if not understanding, you can put it. Bharat, definitely it is a 12th class chapter. If you listen it, it will help you out in the next class or next year. Okay, it is a 12th class chapter, but 12th class first chapter it is. So not for 11th, but if you listen it, definitely it will help you understand. Okay, Arjun, please focus on the class, beta. Now, this is bubble 1 and this is bubble 2. When we are discussing bubble 1, in bubble 1 you will see this one so bubble is there and I'm putting the charges. Now we know one thing, when we are putting the charge, this positive, they are like charges. They will attract or they will repel each other. Definitely repel. In the starting I have discussed the like charges repel each other. So they are going to repel each other. Repel, that means the point charges, whatever placed on the surface they want to move away from it. So they are moving away. That means every point, every place on the bubble, every place you will see they are going away. That means the area of this bubble is going to increase. Area of this bubble is going to increase. So you can see very simple, the area of this bubble is going to increase with the time. Similarly, if you go for the negative charge, they are also like and like charge. The like and like charges, they will also attract or repel. Definitely they are also repelling each other. When they are repelling each other, then what will happen? They are also going up, moving apart from each other. They are moving apart from each other. That means what is going to happen? Their space also going to increase, area also going to increase. That means again the soap bubble is going to, area is going to increase. That means here also the surface area is going to increase. Here also surface area is going to increase. That means their radius is going to increase, their size is going to increase. Very simple thing, you can put it. Ramadevi, 4T by R, you are telling actually good, but this is the axis pressure, you are telling it, but I am not asking axis pressure. I am interested in what is the effect will occur on the this area due to putting this or radius or volume of this soap bubble. That is my question. So you have to understand. Okay, so please understand it. I think now it is clear, beta. Ramadevi, you can answer it if it is clear, and other people also please you can put it. Okay, it is clear or not clear, beta. Ramadevi, beta. Yeah, I understand 40 by R. That is the axis pressure. That is not axis pressure I am asking. I am asking what is the effect on it. Okay. Now please understand. Now come to the next question. Next thing we are going to understand. This is the method of charging. I will discuss tomorrow, and this Coulomb's law also we will discuss tomorrow. But today we will we can see one more thing. Very simple. That this method of charging. I will give you the idea about it today, and we will discuss tomorrow in details few things related to the questions. Okay, numerical question. The very first thing is the charging of by friction and charging by induction and charging by conduction. Very first thing, by friction, by induction and by conduction. These are few points you have to understand. The very first thing, friction. Just now I explained there are two bodies are there. Suppose this pen is there, this pointer is there, I am just rubbing it. Okay, and when rub it, or I am taking this pen, I am rubbing with my dry hair, then what will happen? It is charged. Another part or comb I am taking it, or one glass rod and silk is there, or cat fur is there, ebonite rod is there. I'm with the silk, I'm just rubbing it. Then some charges are coming on the bodies. So you have seen that kind of very fixed simple pictures in the movies also, some YouTube also, and some books also. You have seen that kind of picture. The one girl is there, it is touching one we can say one ball, metallic ball is there, some charge system is there. We will understand with the time what is that actually. Okay, and from that what is happening, the hairs are just standing. So what first question also comes to our mind, why the hairs of the girl is going to stand. So that is another question, so we will understand, but these are charging part. Okay, now come to the static charges. I am taking this body and another body, I am just rubbing it. by rubbing, the one body become positive and another body become negative, because charge is a conserved quantity. So whatever number of electrons are moving from one body to another, then one body become positive and another body become negative, and their charges would be opposite nature. When we are saying this is the friction, then charges would be charged body. Okay, their nature would be, nature of charge would be, nature of charge of opposite nature. Opposite nature. It's the opposite nature would be there. Try to understand. That means one would be positive, then another would be negative. Second thing you have to understand, the amount of charge would be equal. Amount of charge would be equal. Would be equal. Another part. So it's very simple. If initially bodies were neutral, I'm assuming it. Very simple. If it is assumed in the neutral form, then you can talk about this. I'm taking another part. Due to conduction, first I'm discussing here. What is the conduction? For conduction, by name it is clear, the bodies would be conducting. When bodies are conducting, so when we touch one body, one charged body to the another body. Suppose I'm taking this is one conductor, I'm assuming it. So I'm taking this body and I'm touching to the another body. Then what will happen? The charge will go on this body. On this surface, it will distribute. How it is distributed, uniformly, non-uniform, that is the second question we will discuss with the time. Not right now here. Suppose this one body is there. It is, I'm assuming it, any irregular shape. Another body also irregular shape, and I'm just touching it with the wire. Initially, I'm assuming, suppose this is the positive charge on this body. Body A, I'm just saying it. It's the body A, and this is the body B. Initially, there are no charges there. Okay, and I'm collecting with this wire. So due to this wire, the some charge will flow from body A to body B. Now, question comes to our mind, what will happen? The positive charge will move, or some electron will move from B to A? Okay, you can answer in chat box, but I'm replying here. Because B is neutral, I'm assuming it. Both are conductors, and this A is a positively charged. So definitely proton cannot move, so electron will come out. The electron will from B will come to the A, and then what will happen after some time? We will see that this is the A body, assumed to be both are same picture. Okay, I'll try to make it a similar kind. Okay, so this is a very simple. I'm just rubbing it. You will see. Assume to be both are similar. Okay, so what will happen after some time? We will see ki on this body also it would be positive charge, and on this body would be also positive charge. That means nature of charge would be same. Nature of charge would be same. Try to understand. But remember, suppose initially it was a Q charge. Okay, initially Q was charge, but it will remain constant with the time. If you see final, this becomes suppose Q1, it becomes Q2. So it's Q1 and Q2 if added by additive property, then also you will find that is equal to capital Q only, and that is also constant. It is not going to change it. Try to understand it. So total charge of this in the conduction does not change, it remains same. But what is happening? Both body can have different amount of charge, correct? But their nature would be same. If both are, one would be positive, then another would be also positive. One is negative, then both another would be also negative. That means the nature of charge will come of same nature. It will not of a different kind. One thing. Second, you have to understand the charges of same nature and amount of charge can be different. But when we talk about the friction, the nature of charge would be opposite nature and their amount would be also same. That is the difference between the two processes. When we are talking about the induction, now you have to understand very clearly okay, what is the meaning of induction. Induction actually requires, suppose this one body is there and near to this body I am taking another body is there, not touching, I am just putting near to it, just near to it. It is a conducting body. Conducting body. okay, and it is placed over a insulator. It is placed over insulator. Try to understand it. Now when I'm taking this positive charge near to this metallic body or conducting body, then you will see this side what is coming, negative charge will come. Why it will come? Try to understand. Because this is a positive charge. Positive charge will attract the negative. Negative means electron. That means this is the conductor, and conductor having a large number of free electrons. A large number of free electrons, that means this electron can displace, they can redistribute from one place to another place. The electrons are moving toward this side. Then this side would be little positive side. This is little positive side, this is little negative side. Then you can see this is the charge is coming on this picture. Now question comes to you. Now this body, sir, it is looking like good. Okay, this is negative minus q charge, suppose this is plus q charges, very good. But overall it is neutral. We want some charge, sir. You told us that there should be some charge. How it is possible? So for that you have to put some what earthing here. You can put earthing. Now there can be some confusion also. Sir, what will happen? Earthing should be in this side or this side. You can put anywhere, it does not matter. Just put the earthing, but keeping this body here only. Keeping this rod here only, then only it is possible. Then you put the earthing. Then due to earthing, what will happen? Try to understand. This is positive. It want here negative. It is negative. It is what? Positive. This would be neutralized by this earthing. And due to earthing, because we connect with the earth, and earth is, we assume, very big and neutral body, as we are assuming it. We assume it, earth is very neutral. Okay. Then what will happen? The some charge will go from earth to this body. What is the charge? Electrons actually is moving. Because electron can only move, proton cannot move. So electrons are moving from the ground and reaching and making this neutral. When this you are making neutral, then after some time you will see that this body is having only negative charge. Now you can remove the earthing, you can remove that body also. So this is having overall neutral charge, that is equal to minus q. So this body, what outside body we are putting, this rod I am putting it, that is equal to what beta? Positive. But this metallic ball is getting what beta? Negative charge, opposite charge. I am not saying equal charge, because what is the meaning of equal or unequal? We will learn with the time. That is the polarization word. We will understand it with the time or induction in detail. But today I am keeping class up to here. Tomorrow we will discuss from here onward, that is equal to Coulomb's law. Okay. My expectation, tomorrow you will be in the, okay, you can be in class little more focused, and my request to all of you, and you can put your comments, you understood or not understood. I'm just waiting for just 1 minute, and then I will leave the class. I'm just waiting for your comments. Please put you understood in the class or not. Arjun and Fruity, please you can move out of the class. There's no meaning of it, beta. Okay. Please put your comments. I will just waiting for your comments. You understood or not, beta? Okay, Prajit, very good. Yashashani, good. Checking. Posh, my team will answer that question. Don't worry about it. Prem, good. Okay, beta. Thank you. Enjoy your evening. And there's another class is there, chemistry. Please focus on that class. Please move. The other persons who is putting the spam in the class, you can move out of the class. Just stay away. Okay. Thank you so much. Bye bye.